Quick introduction to William Lucas. William Lucas is a software engineer working for Percival Engineering since 2018. His skill set includes reverse engineering, emulation, development, vulnerability research, and he holds a MS in computer science from Georgia Institute of Technology and a BS in computer science from University of Maryland, Baltimore College. So that being said, Billy, feel free to take it away.
Hi, can everyone hear me? Oh, sorry.
Yes, we can hear you now.
Okay, perfect. Thanks.
You may want to take your camera off, though.
Oh, take it off? Oh, to share the screen. Let's see. Might need some AV help. Screen sharing.
What's the problem?
Oh, I think we're okay.
That's okay. You're okay now.
Okay, awesome. All right, so this is Modbus 101. David did a great introduction. I'm William Lucas from Percival. Modbus will be a big part of our CTF. And like he said, I did a lot of the design work and implementation for the CTF, so this presentation is definitely intended to be relevant to what you'll be doing tomorrow. And feel free to ask questions in the chat. I'll do my best to answer them as they come up in case I'm, going too quickly or overlooking something. There we go. So Modbus overview, it's a really old protocol, serial communications protocol, predates the internet from actually 1979. And it's old, and so it's influenced the design of a lot of later protocols of industrial devices. So Modbus is pretty simple. And if you understand Modbus, that gives you a good basis of kind of understanding other industrial protocols. And believe it or not, despite it being so old, it still does get used fairly often. So definitely good to know if you're into ICS SCADA. And so, there's some other automation protocols I list here. So we've got BACnet for building automation, CAN bus, that's a big car thing. There's some good DEF CON talks on that if you want to see people hack into cars. Common industrial protocol, some other ones as well. One big plus for Modbus as well is that it's royalty free. So later on, we'll actually get to use a specification, which is nice. A lot of times vendors kind of have those locked down. So I just wanted to really quickly give background as far as like what a protocol actually is for those of you who might be new to protocol analysis and to Wireshark. So we mean a communication protocol. And so in a general sense, a protocol is really like an agreement. And so for a communication protocol, it's just a set of rules that defines communication, that defines, kind of like an outgoing message, an incoming message, that kind of stuff. And it's important that both sides, understand the protocol, or else you're not going to have devices able to talk to each other. Another thing to note with Modbus is that the protocol is pretty simple and pretty loose. So, is everyone able to see the screen large? I see something in the chat. Just want to make sure that everyone's able to see my slides.
Yes, we're able to see your slides.
Okay, perfect. Sorry about that. So, so basically, let's see. So Modbus is a simpler protocol. It doesn't have a lot of rules as far as what the data is in the communication. That could be on a device-specific basis or really on a command set-specific basis, which you'll see in the CTF. And some other common protocols that you might be more familiar with are IP, Internet Protocol, TCP, UDP, and then HTTP. And so let's see. So protocol analysis, we kind of talked about some of this stuff, but I guess we didn't. So you can just look at raw data. You can just look at the bits and bytes, kind of getting sent from point A to point B, but it's really not a very useful way to learn about what's going on unless you're working with a really simple protocol. And Modbus is pretty simple, but you'll find that using Wireshark is very convenient. So Wireshark, for those of you who don't know, super useful CTF tool and really just useful tool, period, if you're doing anything security related, anything SCADA related. We use it, daily here at Percival. So Wireshark allows you to sort of visualize packets, and for a particular protocol, they call it a dissector, where it sort of pulls it apart and kind of gives you more context that isn't present in the actual data, but it'll be displayed for you in Wireshark, and we'll have an example of that on the next slide, and then time permitting, I'll actually pull up a packet capture in Wireshark. And that kind of leads me to the next point where Wireshark does packet sniffing or packet capture. Basically, it allows you to listen for traffic on a network interface and record that. You can both kind of look at it immediately, but also you can save it off, send it somewhere, do whatever you want with it. Yep. So here's an example. This is of HTTP. So this is just web traffic, right, unencrypted. And you might be able to see, I'll go into more detail, time permitting with Wireshark once we get to the sort of hands-on example. But this top window, each row is a packet. And then the middle window and the bottom window, these are all based on the currently selected packet, the one in blue. And so the details aren't important, but just at a high level, this middle section shows the packet that's in a way that's dissected, where Wireshark knows a lot about the protocol. And they'll kind of give you more context. But the bottom here is just the sort of raw data. And then it's in I think it's hard to read, but it's kind of like a more hexadecimal representation where my mouse is. And then later on, it's in sort of a text decoded representation. So it's probably hard to see, but what I wanted to just mention is that, HTTP is very much human readable. Modbus is less so. So having that dissector will be really useful. I'm going to see if I can just tab this slide. Okay. So kind of getting back to Modbus in particular, Modbus is a client-server protocol. You'll still see a lot of the older kind of master-slave terminology, same kind of implications. And the client communicates with one or more servers. So it's kind of for lack of a better word, you could kind of describe it as like point-to-point. There's not some, arbitrating thing in the middle. It's just, a client will reach out to a server. Client will ask for stuff. The server will reply. A client can, connect to multiple servers, all that kind of stuff. And it's not even, I say connect. Modbus can use TCP, but it doesn't have to. We'll get to those details a little bit later. So common clients are remote terminal units such as PLCs. Basically, just like kind of like SCADA ICS devices are typically the ones using Modbus. And so they're common clients. They're kind of smarter devices, if you will. And then you'll have the sensors and actuators like a motor or just something that does stuff essentially. Those are common server devices. The idea is that the PLC is a little bit more of the brains of the operation and might need to know what's going on to coordinate processes, ensure safety, something like that. So it would reach out and pull, it would ask for stuff essentially from the Modbus, the devices acting as Modbus servers. Yep, so now on the next slide we've got a little example. And so this comes right from the Modbus spec. I really like the spec. I'm going to talk about that a few more times in this presentation. It's really good. Some specs are a lot less good, let's just say. And it's really nice that this one's just freely available. So in this example diagram, we've got Modbus communication over TCP/IP, as well as some Modbus communication over various serial media. And so we'll talk a little bit more about the various sort of flavors of Modbus. But this is just kind of conveying what I mentioned on the previous slide, where you can have kind of these smarter devices such as PLCs and to an extent HMIs. So HMI stands for human machine interface. There's going to be an HMI in the CTF. It's going to be incredibly simple and scaled back HMI, but it'll be an important part of the CTF tomorrow. It'll be where some of the higher point value flags are actually going to be revealed to you if you figure things out. So let's see, with that said, so the idea is that these simpler devices, kind of a lot of the ones in yellow, often will just be able to communicate via serial, not always, but that's a really common use case for kind of the older Modbus serial formats. I see a question in the chat. Will there be copies of these slides available? I'll definitely make these slides available, and I think all the presenters are, but I'll defer to someone else about that afterwards. Oh, and the recordings will be available as well. And yeah, please feel free to ask more questions. You know, anything technical related to this presentation, that'd be great. I'm definitely glad to sort of take tangents or explain something. But yeah, moving on. So this is a really simple diagram. This is kind of goofy. It's just like, all right, we have clients writing data to a server, and then the server will, you know, give it things back. The client makes a request, server provides a response. That's pretty much all there is to it at a higher level. And then the server has registers. Those are the ones that are storing the Modbus data. We're going to go into a lot more detail later on in the presentation, because that's really going to be a super important part of what you all will be doing tomorrow during the CTF. And I see a question, will you show an example of how an HMI can be exploited in a CTF? The short answer is actually no. Our HMI is just meant to be readable. You don't want to try to take it down. It's just providing you information. It's not something intended to be hacked. And for tomorrow's purposes, I'm sure that is something that's feasible and has probably been done if you look it up. But yeah, tomorrow's HMI won't be what you're exploiting. It's more, you'll be modifying processes and really the flow of electric power. But that's a great question. So Modbus Security, the short answer is there really isn't any. This is a protocol from 1979, right? So the internet didn't exist. You didn't have this idea of like little kids in their basements on the internet trying to hack into stuff. The idea was if you weren't physically co-located, how would you possibly talk to these devices? Of course, the reality now is different. If you go on Shodan, you know, you can find, if you just search port 502, there are thousands of Modbus devices. Probably shouldn't be on the internet, but you know, some of them are. So communication is in plain text. So even though it's not super easy to understand without looking at the specification or something like that, you're seeing all the communication. It's not like, you know, an HTTPS packet where there's a key that you probably don't have and it's encrypted. So you're able to see everything. There's no authentication. A lot of other industrial protocols have ways to authenticate that simply just doesn't exist with Modbus. Let's see. Let me try to keep the chat a little bit engaged. So does anyone have ideas? I guess just post in the chat about maybe like a workaround or a way that you could send Modbus traffic but make things more secure, even accounting for the limitations of the protocols. Maybe something you can almost wrap it in. I'll give you guys a few seconds. Okay, I see VPN, I see OpenSSL. Yep, I like where you guys are going. So that's the right idea. Tunnel of some sort, perfect. Yeah, so yeah, essentially, right. So Modbus, I think it's in a little bit of a layer slide, but right. So one really common way to send Modbus traffic, and in fact, what we'll be doing during the CTF is Modbus over TCP, and you can absolutely have an SSH connection, and then you're sending Modbus TCP in a way that's secure. VPN was mentioned as well. That works as well. There's also this Modbus TCP security protocol. It's from that same Modbus group. It's a related but distinct protocol. So what you'll often find in SCADA, WiCyS-CIC is that there are these more secure approaches, but they get implemented later, and no one implemented, by that I mean like on the vendor side or the specifications get made, and then no one on the sort of side of the devices really cares to implement it on their end, or if they do, the end users typically don't enable these features. So I think it's like the Siemens, I think it's like the Step 7 protocol They have authentication. Usually doesn't get used, that kind of stuff. So there is this Modbus TCP security protocol, but it's not the widely used one. The widely used one is the really old Modbus that has no security. So let that be a lesson to you. This is the Modbus spec. I promise I'm not just going to read through the spec, but the spec is really great. I promise. It's attached. It'll be attached during the competition, and we can throw it up on Discord if we haven't yet. It really is pretty straightforward as far as these things go. It will be very useful for you during the competition. I'm definitely trying to hit all the important points that you'll need, and the competition will be about building on your Modbus fundamentals to figure out things more towards the process we've designed and the specific command set you're given. But if you do need more Modbus background information, I do highly recommend referring to the spec. It's also linked in this, the end of this presentation. And so this is just the whole table of contents. One kind of goofy thing I want to highlight, or I guess I did circle, is it only has 50 pages. Believe it or not, that's really nice. It's a really small spec. It's a lot more digestible than other ones. And of course that makes sense because it's really old. It's probably older than most of us participating in all that. Let me just check the chat and make sure I'm not missing anything. Okay. Yeah, I see some people are answering some of the kind of broader questions in the chat, which is fantastic. Once again, if there are more questions for me, I'm keeping an eye out for that. So this slide is common Modbus function codes. So you'll want to be using a lot of these for tomorrow's event. So Modbus has various function codes, and we'll get into more of the frame structure later, but there are various codes that are sent as part of the packet, and they essentially indicate what kind of operation you want to perform. So there are different data types, and depending on what data type you want to read or write to, you'll have to send a particular function code. All of this is spelled out in the Modbus specification as well as in some other slides, and you can definitely find a lot of online resources about Modbus. It hasn't changed over the years. But I would recommend getting familiar with the specification. I've kind of fallen into this trap before at work where sometimes it's nice to have an online reference, but sometimes you're also losing information from, the kind of source material that really defines what's going on. So, always refer to the spec if possible, especially for something like Modbus where it's freely available. So this slide's got all the documented Modbus function codes. Does anyone have an idea why we're saying all of the documented ones? Or like what Modbus function codes could there be that aren't documented? I'll give you all a little bit of time to mention. Perfect, yeah. So Vincent's got the right answer. Yep, vendor, proprietary, OEM. Excellent, yep, so you guys got it. Yeah, absolutely. Vendors are free to define their own Modbus function codes as long as they don't conflict with the sort of one spelled out in the spec. So that's what you'll find a lot where, a protocol kind of provides a base. And then I know in a lot of other, I'm pretty sure Common Industrial Protocol, SIP, is the same way. I think that's a really common thing to allow vendors to define some of their own function codes. So the documented Modbus function codes are really the ones that we'll be focusing on. But just keep in mind, if you encounter Modbus in another scenario, it's certainly possible that a vendor has defined their own code. So let's see. So Modbus variants might have been good to have the slide a little bit earlier on because I've sort of referenced around this a little bit. But so there's Modbus RTU. So it data is transported with serial media, and it's got a binary data representation, so it'd be pretty hard to read. Modbus ASCII, it's still serial transport, but it's a little bit more human readable. Still wouldn't recommend it, to be honest. Definitely use something like Wireshark if you can. And then there's Modbus TCP. So data will be transported with TCP packets. The conventional, the well-known port for that is port 502. So that's a big thing during the competition. Might be a really good idea to use Nmap. Might be a really good idea to make sure that you're scanning for port 502. By default, Nmap only scans for, I think it's the most common 1,000 ports. To be honest, I don't know if 502 is in there or not. So to be safe, you could specify -P502 to scan for that port. Let's see. So yeah, so the serial ones, the serial transport, Modbus RTU, and Modbus ASCII, they have a checksum. But one of the really cool things about Modbus TCP, and really just the really cool thing about sort of the like networking layer setup, OSI model, and all that, is that you can utilize, components of other networking frames, of other networking layers. So TCP already has checksumming built in, so that no longer needs to be sent as part of the Modbus packet. And that's also Modbus over TCP is the same reason why you can then use that to send Modbus over sort of an encrypted tunnel, like was mentioned before with a SSH or a VPN. So we'll just be focusing on Modbus TCP for the CTF. There won't be any serial devices, but everything we've talked about will apply to that. So this is the frame format. We're getting a little bit more into the details let's see. Yep, so a little bit more into the details of like how Modbus data is structured. So we've got transaction identifier, protocol identifier. So those will kind of, that helps the server or client understand it's like sort of which message am I responding to and that kind of thing. It helps correlate things. Length field, pretty straightforward. We've got unit identifier. You might also see that as slave identifier. Wireshark will probably break it out as that. Function code, that's a really important part. I think someone asked you up in the chat, are those functions called just by their code? This pretty much, the function code is part of what goes into a Modbus packet. And then just the data bytes. So that's where I was going earlier, where you can you can kind of send whatever data you want within your Modbus traffic, and it's kind of on the party on the other side to interpret it as you intended. So that's going back to that whole protocol thing, that whole agreement thing. If the other side speaks Modbus, it should be able to realize that, oh, those are those data bytes, I got that information. But the tricky part is after that, there needs to be sort of another layer of understanding between the server and the client. Oh, and I see, very nice. I see FIDES. I hope I'm pronouncing that right. Awesome. So you looked into TCP port 502 is not part of the default port scan for mmap. So that's really good for you all to know. But sorry, so getting back to the whole data bytes thing, it's sort of what bytes you get back are really just defined based on like the data sheet that you're looking at or the command set you're using. So that will be part of the competition. We'll be sort of leading you towards, but also forcing you to identify what command set some of our simulators will be using, and therefore understanding, hey, this is this function and all that, but essentially it's like, okay, what do those bytes represent? Are those bytes, representing integers? Are they representing text values? There will be some like that. Are they being scaled in any way? All of that extra specification is not part of the Modbus spec. Instead, it's part of a data sheet, if you can find one. Any other questions before we move on? We're getting pretty close to just a little demo section at the end. Okay. So this slide is kind of meant to be a reference for you all during the CTF. This is I kind of tried to distill what I think is probably the most important bits of Modbus background that you'll want to have. So there are only, that one got cut off, but that's fine. There are only 4 data types. There are only 4 different Modbus data types, and they each kind of have different length, or not each of them, but some of them do. So to be clear, we've got coils. So those are read writable, so you can read from them. You can read from everything in Modbus, to be clear, but you can also write to coils. And their data type is Boolean, kind of like a true false 0 1, right? So it's only 1 bit. There are also discrete inputs. I personally find the naming to be confusing of what's readable and what's writable. So discrete inputs are actually read-only, and they're read-only single bits, Boolean once again. And so input registers are also read-only, and those are 16 bits. Those are uint 16s. So the two things with inputs in them in the name are actually the read-only data types. And then holding registers are read-write uint16 as well. One other point of confusion, frankly, it was a point of confusion for me when I was designing these simulators, was that there's some weird numbering and addressing and all that kind of stuff. So what's conventional is in Modbus is to refer to register numbers starting from 1. I'm not quite sure why. There might be a historical reason. I'm personally very frustrated with that as a programmer. But then, so that's kind of what you see in this column with coil or register number. But then if you see protocol data offset, it's representing the same stuff. It's just that register number 1 refers to actual address 0. It's kind of goofy. It's just off by 1 thing. So if during the competition you think you know what you're supposed to be reading or writing to, maybe see if you're not off by 1 somewhere. And a couple of the simulators might even treat things differently, which I know is frustrating, but it's also how things actually work with physical Modbus devices. These address ranges, like it's mentioned here, are conventional. They're not hard and fast rules, but that's pretty typical, and we mostly stick to that in the CTF. Let's see how much time we have. So we could do the online one, or we can do, I think let's pop up real Wireshark. And feel free to ask questions, not only about Modbus, but also even about Wireshark in general. I'm sure for a few of you, this will be the first time you've seen Wireshark, and I'm glad to kind of, explain some of those kind of details or fundamentals. So let me try to switch over to the PCAP here. Okay, so this is Wireshark that I've got open. Oh, sorry about that. Let me make sure everyone can see it. I think I have to exit the presentation. Okay. Sorry, bear with me for just a second. Okay, great. So this is the Wireshark window. And so it's free, it's open source, it's available for Windows and Linux, and I'm sure probably Mac and other platforms. I see, so buffer plus 9 is data in Modbus. I believe that's true, and actually we can answer that question right now kind of by going through the packets, because I do not know off the top of my head, but that's a great question. So Wireshark's really got a ton of great functionality. And this one's laid out a little bit different. So now we've got, this was the middle one in my screenshot, and this was the bottom one. So you're able to move the windows around. But this top part here where I'm clicking into is, has a row for each packet in your capture. And see how this kind of changes per packet. So bottom left right now is the dissected kind of protocol view. Bottom right is the raw data view. So the first thing I'm going to do is filter to only see Modbus packets, and then I will try to answer, I believe it's Anuja, I'll try to answer that question from the chat. So all I did was I just typed in Modbus. So in Wireshark, you can filter by protocols. You can filter by a lot of different things, but protocols are probably one of the most convenient things to filter by. So I just typed in the name in this kind of filter bar up here, hit enter. I got it's showing green because I think that's just because the filter is parsed as something valid, is my understanding. So let's just look at that first Modbus packet and let's try to get an answer to that question. So if you all are familiar with the OSI model, Wireshark kind of is chunking this packet into layers. So if you look, and it's really nice, it correlates what's on the bottom right with what's in the bottom left, kind of with what you're selecting. So right now you're kind of selecting the entire packet on the wire, but as you go down and you just drill down into various sort of layers of the packet, it'll show the byte representation on the bottom right as you kind of navigate through it. So to start answering the question, let's look into the Modbus TCP packet, or Modbus TCP layer. And so we see this is 2 bytes. Wish I could pull up the slide at the same time, but I don't think I can fit all that in the window. But so we've got 2 bytes. So each one of these guys, these single guys, is a byte. So like I'm clicking on one byte here, and then I'm clicking to the right. I know it's hard to see, but basically that blue highlighted region is 2 bytes. And so that means the quick see if anyone's paying attention question. So theoretically, I can't say for sure there's not any like goofy built-in stuff to Modbus. You'd have to check the spec. To be honest, transaction identifiers won't be a super important thing for the competition. But theoretically, if this is 2 bytes, how many different transaction identifiers would there be? So if anyone would like to answer that in the chat, I'll keep an eye on that as I kind of keep going. So we've got 2 bytes for transaction identifier, 2 bytes for protocol identifier, 2 bytes for length. So this should be the length of the data section of the packet. And then just 1 byte for unit identifier. Okay, so they changed it. So this is what used to be known as slave identifier. Now it's been updated to unit identifier. And as you can see, this is just a single byte. I remember that this is the reserved field. So I think they're up to 247 you're allowed. I think one of the bits is reserved for something else. Or I think it's 8 of the possible identifiers are reserved. Okay, great question. So this unit identifier, what does it signal? What does it signify? Pretty much, the idea is to allow for sort of being able to have concurrent connections. So a Modbus server could actually serve different values based on the identifier used to connect to it. It's just something that you'll want to make sure you have right when you're talking to a device via Modbus. Some devices don't care and serve the same thing no matter what your slave ID is. So especially some of the earlier ones you'll encounter will be kind of nicer like that. But yeah, it's worth looking into. For this competition, we won't give different stuff depending on the unit identifier. That would be pretty mean. So as long as you're able to communicate with something over Modbus, you essentially have that identifier right. So I want to go back to Anuja's first question, because now we can really answer this, right? So so buffer plus 9 is data in Modbus. So I think that went off of the diagram. So that's a really great question. And that appears to be correct, right? Because we've got 2 bytes, an additional 2 bytes for 4, another 2 bytes for 6, 1 byte for unit identifier, that's 7, and then the function code, I believe, okay, function code is 1 byte, and then, okay, diagnostic code appears to be 2 bytes. So I think that totals to 10, if I'm understanding correctly. But look at that, the length of this is 6, so it seems like they tried to be extra nice, and because of the function code, the dissector was able to identify the diagnostic code, but technically that's part of the data section. So to me that means, yep, that Anuja is spot on. Buffer plus 9 is data as far as so from the start of the Modbus packet, if we go 1, 2, so this is buffer plus 1, 2, 3, 4, 5, 6, 7, 8, 9. I guess if you're starting with a buffer, assuming that you're starting at 0, I think it would be plus 8. But you have 9 bytes in between the buffer and data. Let's see. So I know we don't have a whole lot of time remaining. So what I'd like to do is talk a little bit more about kind of just examples of Modbus traffic, and we can talk about what it actually kind of represents. Let's see. Another really nice feature is filtering of Wireshark is filtering based on just sort of attributes of the packet, things that the dissector understands. There might be some technical term for these attributes I'm talking about. I'm not sure if there's a kind of generic catch-all term for that. So what I'm going to do is I took this diagnostics one, and frankly, we don't care about this. A diagnostics thing is kind of sometimes they try to have these little connection things. Sometimes you might hear heartbeat, where it keeps up with, it's sort of oh, is this device active? A lot of these, Modbus is, like I mentioned earlier, primarily used for SCADA ICS things. A lot of those can be really important. They could be mission critical. They could be, have some important production thing, or at minimum, people are really invested in wanting to know, hey, if something goes wrong, if this thing is inaccessible, they want to know right away. So to be honest, I'm not very familiar with the diagnostics function, but I would assume it's one of those constantly reaching out and asking what's going on thing, and we'd see it periodically throughout the rest of this. But what I want to do is I actually want to ignore it for now. It's not super important for the CTF. I wanted to go into more detail for some of the read and write packets. So what we're going to do is go into Wireshark, right click, apply as filter, and not selected. So what this is going to say is it's only going to give us packets where the Modbus function code is not equal to 8. And now, as you can see, it cleared our earlier filter, which is kind of inconvenient. So we're going to add that back. We're going to AND the filters together. So this is sort of the C-style logical AND with the double ampersand. And so now we have only Modbus packets that don't have a function code of 8. See other packets. So device identification, that's going to be something relevant in the CTF. There will be a flag for that one. So you might want to keep in mind different ways to query device information. So this would be a really good sort of tool to have. Oh, and I mentioned tool. One really big thing that I should mention, I'll try to make sure, I might update the slides or make sure it's in Discord, because that's a big thing I forgot to include, is how to actually talk to things via Modbus. We don't really have the time or the environment to do it in these next few minutes, but there are various tools on put on the Kali workstation VM for you to use to kind of speak Modbus to communicate with these devices. So one of them is called PyModbus. It's a Python library. It's readily available. It's kind of the quickest way to me to sort of get up and running if you understand how to code in Python. It also has a console where it's sort of an interactive thing where you're not really writing code directly, but it's also scriptable. It's a Python library. Another tool that I believe I'm not sure if it's been presented yet or not, but if not, it will be today, is Triangle Microworks Protocol Test Harness. I'm sorry, I see it is so hard to see his shared screen. I will do my best to zoom in. I don't know how much that'll help. Let me know if this is any better. Sorry about that. But so there's also the Triangle Microworks Protocol Test Harness. So that's a GUI tool where you can communicate with Modbus. So what was the second cool tool called? I will respond in the chat. So we've got PyModbus, and then I have this set to direct message, and TMW Protocol Test Harness. These are the two tools I mentioned. There are other ones you might see online. I think there's like Modbus PAL that simulates like a Modbus server. We're not using that one, but that's another option, another open source thing to play around with. But yeah, we've kind of set you up on the VM with tools that should work nicely, I think, for the competition. The intention is for you to not need to download anything else from the internet, but you are more than welcome to do so. Let's see. So one big one I wanted to show is just reading a coil. Right. So we've got really the important stuff here. This part is actually kind of less relevant for a lot of what we're doing. Yeah, you want to make sure you get the unit identifier right, but you'll get an exception if you don't. And I could show the relevant section from the spec if we have time. But really, the important stuff is the actual Modbus sort of data, the function code, and then the associated data. So we are sending function code 1, which is just to read a coil. Or to be fair, it could be used to read multiple coils, but we have the bit count as 1. So if you see here, we should get an associated response. Usually Wireshark kind of correlates it nicely for you. I'm having a little trouble navigating. Okay, yeah, so we've got the response right here, right below. And so this is saying, hey, you asked for bit 0, and that's what you got. You got the value back. So the value is false or 0. And we can move on to something a little bit more interesting. So this one's a read holding registers call. So this is function code 3, and all these should match up with the spec and with what's in the slides. And here we're reading 2 words. So we are reading, and a word is a uint 16, and we should get data back for both. So really all the important stuff is already included in this dissector line that it kind of gleaned out of these two fields that are within the packet. So, yep, any questions on that? So basically for read holding registers, you're saying where you want to start reading, as well as how many you want to read. So depending on what you're doing, you might want to read multiple registers. If you're saying, oh, hey, I know that all 20 of these are available and I'm expecting them to change. Likewise, if you're getting an error, if you're getting some sort of exception, I can pop over to the Modbus spec really quickly. Okay, let's see. So if you're getting some sort of exception that, I think it's something like address out of bounds or something like that. It's a little bit more specific. And this will be something mentioned for the in the CTF. Then it would be a good idea to say, oh, maybe I read too many things. Maybe I read a register that is not that is basically not implemented or not supported, and you could get an error code for that. You might want to instead only read one at a time. So sorry, I know this is a little messy. I think it's invalid address. Okay, well I don't want to, oh, here is the table. So these are things to keep an eye out for, these Modbus exception codes. Either tool you use will display them, if it happens. So an exception is kind of like an error, right? It's like something unintended, something a little bit bad happened. So a legal function means that your function code was not recognized. A legal data address means that you did something that was understood, but it was asking for a data address that isn't valid, or at least isn't supported for your type of function. So you got server device failure that's more sort of generic, kind of like anything went wrong. You might see that a lot. Yep, so I see one more question. That's probably all we'll have time for. So it says, any tips on parsing the response data or how to identify interesting responses? That's a really great question. I will say that you won't really need to do any sort of bulk PCAP filtering or things like that. Nothing too crazy. It's more about you should have an idea of what you're requesting, and that is based on sort of the process. That's based on whatever data sheet you might find, or for one of them you might actually have to reverse engineer sort of what's what. But if you have an idea of what data you're requesting, the response value should typically be pretty decipherable. Any other questions before we wrap this up?